So, good morning, everyone. I'm Martina Lilla. I'm very happy to be here in this jsday 2023 conference today. And today I will talk about an example of a solution using JavaScript for multimedia file management in web applications. So before starting, you can scan this QR code to get the slide. So you can take them. Okay, I'm a software engineer in Syndiag, where my work mainly focuses on development and maintenance of the web application. Besides that, data management and engineering for artificial intelligence algorithm, using Angular, NodeJS, MongoDB, and AWS as main technologies. I love technology, and I'm constantly curious to learn new things and design new innovative solutions collaboratively effectively with the end user. Who is Syndiag? Syndiag is a company that offers digital and artificial intelligence solution to support in the early diagnosis of gynecological tumors. So we are a team of 9 entrepreneurs, scientists, and engineers. So our team members, each of our team members, are involved in many and different development areas. Each working in the healthcare field is I can say that is very rewarding because you know that every day you're making a positive impact. But it's also difficult to work in the healthcare field, and each one of us has found ourselves to manage and find solutions to complex problems. So one of the problems we faced is that in Syndiag web platform, where we host services offered by Syndiag, users, that in our case are doctors, upload large quantities of images and videos coming from ultrasound machines. I don't know if any one of you have ever dealt with extracting files from medical devices. Raise your hands if you know what I'm talking about. Okay, so perfect. So I say you that the difficult is in the fact that very often these medical devices extract files in particular extensions, such for example AVI for video or TIFF for images. The problem is that the browser doesn't support any media file format. Syndiag therefore had to face a challenge in its data management flow to properly manage conversion for these files. Even if Syndiag operates in the healthcare field, a similar problem can also occur in many other companies and sectors. So think, for example, about other kind of medical devices such as CT scan or radiography, but also, for example, IoT devices, such as, for example, camera to monitor your home remotely via app, or, for example, robot for industries or drones. Even the users themselves, when export videos, chooses the AVI format just because it's the first in alphabetical order, unaware of the fact that this not then will be viewable in web applications. So we as Syndiag decided to answer the challenge by exploiting ffmpeg, that is an open source software project to manage multimedia files. And in particular, we created a service using Node.js, and in particular, the NPM package manager of Node.js provides us with a module that is called fluent-ffmpeg to use ffmpeg in our Node.js projects using Typescript. So we deployed this service using AWS Lambda. So the expected flow of the implementation is made of the following steps. First of all, when the user uploads a new image or video from an ultrasound machine, if the extension is not among those supported by the browser, a conversion pipeline starts, triggering an AWS Lambda execution that is responsible for the conversion of this multimedia file to be then available for users, so for doctors. But let's go back a step to give some context about multimedia file extensions. So, because multimedia files can be large, programs called codecs were developed to make them easier to store and share. So, file extensions are containers for these codecs, and in particular, these files are compressed for store and share, and then decompress for viewing and editing. The problem is that there are some extensions that should be avoided for web content because they don't have a wide browser support. So, for example, if we analyze this table about the most widespread extension for video formats, we discover that MP4 and WebM formats are compatible with the browser, while MOV and AVI are not compatible. And these formats are very often used in medical devices. So, similarly, if we analyze this table about images extension, fortunately in this case we discovered that most of them are compatible with the browser, but as you can see in the last line, the TIFF format, which I myself didn't know existed before working at Syndiag, is not compatible. And we once received over 2,000 images with this format. So to manage conversion of these files, but also a lot of other operations, we decided to use ffmpeg. I don't know if you know this tool. Raise your hands if you have ever used it. Okay. Perfect. So you should know that is an open source software to manage multimedia files, and it is used by many companies by a mile across various industries. For example, some examples of projects or websites that use ffmpeg and which ourselves use every day are Google Chrome, YouTube, TikTok, or Vimeo, for example. And this is because it can handle a very wide variety of extension for files with minimal fuss for the user. So for Syndiag, it was the perfect choice, not only for conversion stuff, but also to perform a lot of other operations regarding computer vision and artificial intelligence algorithm. So, since we are actually using TypeScript and Node.js in our full stack projects, we decided to continue to use them, because in this way we have consistency between projects. That means less worries and more productivity for the user and for the developer. We were lucky in this case because the NPM package manager of Node.js provides a module that is called the fluent-ffmpeg to use ffmpeg in your Node.js projects. So to use ffmpeg directly or to integrate it in your projects, you have first to install it in your local machine. So after the installation, you can proceed with the installation of the fluent-ffmpeg module, and then just import the module inside the files where you need to use it. So ffmpeg, fluent-ffmpeg provides a constructor that you can use to instantiate ffmpeg commands. So, and the good thing is that you don't need to explicitly define the input extension or the output extension, because if they are already included in the input and in the output path, ffmpeg will do the job. So, for example, in this case, we provide an input path to the input method and an output path to the save-to-file method, and ffmpeg will perform the conversion. Also, ffmpeg allow you to perform a lot of other interesting operations. I'm not going into detail. This is just an example to show you how many operations you can perform at once. And in the link provided, you can find all the available commands and options to use with ffmpeg. And the fluent-ffmpeg module itself provides a set of built-in methods to perform a lot of interesting operations. So our goal in this case is to perform the video conversion. So as I said before, it is sufficient to declare an input video path with that includes itself an input extension and an output video path for the converted video. So in this particular case, we have a local input video path that has an input extension that we expect to be, for example, for video conversion, AVI or MOV, while in the output path, we have an output extension that we imposed to be MP4 as stated in the first line of the code. So it is sufficient to declare the local input video path and pass it to the input method, as well as define the local output video path and pass it to the save-to-file method. Another very interesting thing we can do using fluent-ffmpeg and that we in Syndiag actually are doing is creating a thumbnail of the video for our users, so to show a preview of the video for the user. So to do so, we can exploit the screenshots method that the module fluent-ffmpeg provides us, and this method allows you to create one or several thumbnails for your video. And you have to pass some options, an object with some options, such as the folder, that is the output folder where you want to put the generated thumbnail. Then the file name, so the name that you want to give to your thumbnail, that in our case is thumbnail.png, as stated in the first row. And timestamps. Timestamps is an array of timestamps where you want to extract the thumbnail. So in this case, by providing 50%, we are saying to extract a single thumbnail in the middle of the video. But how and when to perform all these operations using fluent-ffmpeg? As said previously, these sets of commands resides inside the code of an AWS Lambda function. To create an AWS Lambda function, some ingredients are required. So first of all, we need Lambda resources. that are the Lambda function itself, and you can choose Node.js, Python, or Java for the function code. Then we need a zip file archive containing the deployment package, and we need an access policy to grant Amazon permissions to invoke the function. Then we need the AWS identity and access management resources. So in particular, you have to create an execution role to grant permissions that your function need. And in particular, you can find instructions on how to create this execution role in the link provided. And finally, we need a trigger event, because for Lambda to execute, an event must occur. So think about if-then. So if an event happens, then the Lambda will be triggered. There are a lot of types of events that can trigger your Lambda, but for example, the three most used are, first of all, S3 events. S3 events means that when someone or something modifies the content of an S3 bucket, the Lambda will be triggered. Altering the content of an S3 bucket can be achieved either by creating, updating, or removing a file. And when you define the event for which you are interested, you can specify in which kind of event you are interested in. So if it's creating, removing, or updating the file. Then the other kind of event is API gateway. So it means that when someone or something call an API gateway, the Lambda will be triggered. And finally, we have DynamoDB table streams. So it means that when a record in a DynamoDB table is updated, it will trigger your Lambda. For our purpose, the event in which we are interested in is S3 event, because we are waiting for a new video to be uploaded in our target bucket to convert it. So imagine that our target bucket has the following structure. It is called scene-diag multimedia files. And we have a set of subfolders, each subfolder about different types of multimedia files. So we are referring from now on with that of videos. And inside this videos folder, we have other multiple subfolders, each one representing a single video. And the name of the folder is the video ID. Inside each one of these folders, we have all the related content about that video. So, for example, the different formats we have available for that video and the thumbnail. So, but when our Lambda is triggered by a new video upload event, how can we actually use ffmpeg inside it? We have to attach a layer containing ffmpeg in our Lambda. And to do so, you can find, for example, in this case, some public ready-to-use Lambda layers that you can attach to your Lambda, so directly specifying the ARN of where to search the layer you want to attach. But attaching a layer with ffmpeg is not sufficient, because we want to use the fluent-ffmpeg module, actually. So, to do so, we know that a Lambda function is made of scripts or compiled programs and their dependencies. And to deploy a Lambda function, you use a deployment package. And Lambda supports two types of deployment packages. So they are container images and zip file archives. So we decided to use a zip file archive. So in this case, it is sufficient to declare the fluent-ffmpeg module as a dependency in the package.json file, being it included in our zip file archive. So let's go deep into our Lambda. So the main operations you want to perform in your Lambda are described in the index.ts file, and you have to describe, to list all the operations you want to perform in the handler. So let's analyze step by step what we are doing. So first of all, we need to extract the video ID that caused the execution of our Lambda. So to do so, in the src key, we get from the event object the object key of the video. And then we have also to check that the extension is the one expected, because otherwise there is no need to execute this Lambda. And the other operations we perform are to build local paths, to use ffmpeg, and to perform the video conversion. So where to download the original video, perform video conversion, and so store the converted video. So the next step is to download the video from the S3 source bucket. To do so, we use the get object method that retrieves objects from S3 buckets. And then we use the create restream function. That is a function provided by the AWS module for Node.js, and that transforms the request object into readable streams that can then be piped into writable streams, as we are seeing in this slide. So to get this object, it is sufficient to declare which is the bucket, to declare bucket params. So you have to declare the bucket, destination bucket, and the key. So once the download is finished, we can proceed with the conversion of the video. So executing the commands I told you before. So with using ffmpeg, the input method, and the save to file method. It's up to you how do you want to manage errors that can happen during various steps. So once the conversion ends, we can then proceed with the upload of the new converted video into our target bucket. So to do so, we use the upload method that allows you to upload arbitrary sized files, and so we in this case use the same video ID, but this time we have a new extension because we have just converted the video. The other operation we were interested in, and that we also can perform in parallel, is the thumbnail extraction. So, as I showed you before, we can use the screenshots method of the fluent-ffmpeg library to extract the thumbnail for our video. And as in the previous case, with the video conversion, when the thumbnail extraction ends, we can proceed with the upload of the thumbnail in our destination bucket. So you can deploy your Lambda function directly from the AWS console, but as Luciano said yesterday in another talk, it's not convenient to do so. So, for example, we use the serverless framework that also Luciano mentioned yesterday. That is a command line tool that allows you to deploy both the code and the cloud infrastructure following two simple steps. It uses easy and approachable YAML syntax. So you have to first create and configure the serverless.yaml file, and then the second step is to launch a simple command, serverless deploy. And every time you want to update your Lambda function, you just have to launch this command, serverless deploy. So in the link provided, you can find instructions on how to configure serverless. So, in conclusion, after overcoming the challenge, we can list which, from our point of view, are the advantages of the solution. First of all, exploiting cloud services and cloud storage and cloud computing, we are able to manage large amounts of data uploaded by users. Then we have availability. Availability to always have the service up and running from our side, and to always upload and immediately, almost immediately, get back video and images displayed from users, so from doctor side. Also, we have scalability, because as your Lambda receives more requests, it automatically handles scaling up the number of execution environments. And we ended up make our users happier, since that they will never again see the message no compatible source was found for this media. And a similar approach can also be extended to similar fields or use cases with similar requirements. And we developers too can also appreciate the advantages of the solution, not only cloud related, but also, for example, the fact that ffmpeg is open source, making it perfectly scalable to different devices with various hardware specifications, but also in the fact that we are continuing to use Typescript, JavaScript, and NodeJS in other services that are not part of our main front-end or back-end projects. So the last thing that I want to say in conclusion is that in Syndiag we are happy developers, and this is my team of 9 entrepreneurs, engineers, and scientists, and we are a growing team. So if what we do pique your curiosity, don't hesitate to ask me information or contact me. I'm available. So thank you for being with me today.
Thank you so much. There was a lot of information in a very short talk. Are there any questions from the audience about this? I don't see anything. So I have a few things I was wondering.
Mm-hmm.
Did you encounter any restrictions to using ffmpeg?
No, actually no. We don't. You mean legal restrictions?
No, just like the things that you wanted it to do but couldn't, or?
Okay. In my case, I can say no, but my work just has been limited to conversion stuff or something like that. But for example, there are my other team members that works with computer vision and artificial intelligence stuff, so they perform complex operations. So I think that for sure they encountered some problems.
It's a powerful tool, but there might be some things, but I don't know yet as well. Any other questions from the audience? By the way, have you considered any other tools than ffmpeg? Or like, I know back when I was using it was like the only one out there. I'm just curious if it has changed.
Until now, I can say not, but maybe we can try something
figure it out, yeah.
else in the future. Thank you.
All right, thank you so much.
Thank you.